Okay, so let's get started. We're going to be taking a look in this training module at understanding our cranking fuel, our warm-up fueling targets, as well as taking a look at our startup airflow command, which is going to be relative to our throttle angle movement. We have to put all these together to understand how the engine will crank, fire, and run. And we're going to find that it splits itself between direct and port and fuel injection, depending on which specific condition we're operating in. So we're going to be breaking this down and looking at a sample data log that's going to really illustrate how this cold starting process works and how the engine moves into its normal warmed up engine state. Let's jump in here. Let's open up a stock calibration file so we can take a look at a few things. There's a whole bunch of key tables that I want to point out. Most of the time you'll find that your cranking fuel does not need to be adjusted, but you may be in a situation with some extreme applications, such as if you're running flex fuel or you're running, let's say, a huge camshaft that's locked out, variable cam, and has a ton of lift and duration. You may need to jump in and adjust your cranking fuel. So let's look at some of the situations we're going to be in here, and we'll look at our stock configuration to see how this operates and learn which tables we have to work with. What I'm going to do is jump in here to File and then Open. And I'm going to go into our course folder, so HPT Gen 3 Coyote, and we're going to move into our sample calibration file subfolder, and then we're going to move into any of your stock equivalent files here so we can take a look at for reference. I'm going to open up in this case, 2020 Mustang GT manual stock, and we're going to move into our engine tab, and we're going to go here under General, move over here to Fuel. We're going to be working in our General tab, looking specifically at our cranking and priming fuels here. We're also going to be talking about our DI-PI blending that we can find right in here, make a little bit better sense of this, how it transitions between direct and port injection and why that actually happens. We're also going to be taking a look under open loop base, looking at our cold warm-up and our lost fuel tables. This is what gives us a richer command at lambda when we're in a warm-up type of situation. So the engine's already fired off, but it's cold, it's coming up to operating temperature. This is what commands the target lambda. And we have to account for a lot of variables. If we're finding we need to give the engine, let's say, more fuel, then these are the tables that we would start to access and start to dial in and change. Then we also have, finally, under airflow, under electric throttle, we take a look here under our startup cranking. These tables here are responsible for calling out the actual throttle plate movement when we're firing off the engine, which is important because if we give more or less air coming into the engine, that affects the startup. So we may need to also adjust some of these tables, especially if you've changed your throttle body to something huge. Let's say you put a Whipple supercharger on and you're running the stage 2 kit with the Roval massive throttle body. I think it's about 132 millimeter. Your blade position will definitely need to change compared to a stock throttle blade that would move a lot less airflow at the same blade position. So these are tables that may need to be adjusted, not always, but may need to be adjusted to get proper startup and making sure that things are in line. So let's first talk about our fuel side of things. We're going to go under fuel, we're going to go under general. Let's move our way over here into our cranking and priming tables. So we have the situation where we have our priming table first. This gets called on when we turn the ignition key on, and for the first crank revolution of the engine, it's going to spray a huge shot of fuel into the engine. I have never needed to change my priming fuel mass value here for perspective on any of the Gen 3s I've worked with, but it may be something to explore if you're having starting problems. But I probably would recommend not to touch your priming fuel mass. I would recommend, if you need to adjust or touch something, to do your cranking fuel tables, specifically your high pressure mass table here. This is the table that's responsible for probably most of the time, 99.9% of the time, what your fueling delivery is going to be under cranking conditions. So the priming is used to have a huge shot of fuel into the combustion chamber to aid the engine to fire off. As soon as it delivers that, it moves into your cranking fuel. So you have your HP and LP mass. This is calling out the mass flow of fuel that we want to deliver in a specific condition. LP is low pressure, HP is high pressure. We're almost always in a high pressure situation. So this is the table responsible, again, for 99.9% of the situations where if you do need to make an adjustment for cranking fueling, this is the table you'll do it in. You can see this table here is based on engine coolant temp. It's also then based on barrel pressure. Now you can log both in the VCM scanner to figure out exactly where you're at within the table's orientation. So whether you're going to be at 60 degrees or 90 degrees, and then what specific barrel pressure you're at. So pretty simple. It uses this table until the engine reaches about 350 to 450 RPM. That's where the engine control module assumes the engine is running, and it exits the cranking fuel mass table. So simple enough. So this is the primary table. If you do need to adjust and add more fuel, you'll do so in this table. Take a look at our LP mass. This is our low pressure situation. The table's all the same. It's delivering a huge amount of fuel depending on whatever the barrel pressure is versus the engine coolant temp. Again, we typically don't need to adjust this table. It's always going to be, anytime I've ever made an adjustment, it's going to be the HP mass table. Now, in conjunction with these tables, we also see we have these tables FFV, or flex fuel vehicle. So if you're doing a flex fuel strategy, these tables do need to populate it with some values, because we'll find specifically under cold starting, when we're running ethanol, we need to deliver a lot more fuel because it atomizes very poorly on a cold engine. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.